be, a lot of local externalities tend to have relatively flat costs, like doing like playing loud music or something like that it doesn't add up over all the country. So it's not like if everyone in the country is playing loud music, that's that much worse than in terms of its marginal impact than just one person playing loud music. So it makes a lot of sense to just put a tax on doing that, right? It wouldn't make sense to have like cap and trade, to have people trading across places, how much they're allowed to do loud music. Or smoking, there's a very, very steep cost to people who are really addicted to changing their behavior. So it wouldn't make sense just to put a cap on the amount of smoking allowed in the whole economy. It makes a lot more sense to put a tax on cigarettes, right? And this is one reason why most small torts, rather than being capped and traded, are done through the legal system, because they are local effects. They don't add up over the whole country, and therefore it makes sense to just charge this constant tax for them. On the other hand, you can imagine a case where the optimal quantity is well known and is pretty much independent of the costs associated with it. Because beyond some point, it would just be terrible to do any more of it. And below that point, it doesn't matter that much. So this is the case when the marginal externality is extremely steep or inelastic, and the costs of mitigation are extremely flat or elastic. So an example of this is congestion. Like on roads, it makes a lot of sense just to put a cap on how many cars can come on and then allow the price to adjust rather than having a constant price. Because basically, below some level, the more people you have on a road, it doesn't really matter. The road's completely fine. Beyond some point, it becomes absolute hell, and no one even wants to go onto the road anyway, right? So there should be a very steeply rising price, or there should be permits where only a certain number of cars are allowed to go at a certain time. Another example of that is lead in gasoline. Reducing the amount of lead in gasoline, we basically just mandated that no gasoline is allowed to have lead. Why did we do that? Because the truth is that you can reduce the amount of lead in gasoline in a very elastic way. It just has sort of a pretty constant cost in reducing it, so it didn't make a lot of sense to have a price, because you might not know exactly what that cost is. So let me try to give an illustration of this, and again, I'm going to try to use the board this time. So imagine that the total marginal private cost is and the total social cost is very elastic. It looks like that. Now, this would be the optimal point, and that would be the optimal price. But imagine that we don't know quite what the private value is, right? So it might be here, it might be here. Now imagine that we imposed a fixed quantity on this market, right? Then if the demand turned out to be here, but we forced the quantity to be this, right? We would be creating this big triangle here of deadweight loss, or this big triangle here of deadweight loss. On the other hand, imagine that we forced there to be a constant price. Then if the demand ends up being here, we only cause this very tiny triangle of deadweight loss, and this very tiny one here. On the other hand, if we have a very inelastic social cost and a very elastic private benefit, right? Then, but we're not quite sure about what the private benefit is. It could be this, or it could be this. Then if we impose a constant price, we're going to cause this big deadweight loss triangle, or this big deadweight loss triangle. Whereas if we impose a constant quantity, we're only going to cause this small deadweight loss triangle and this small deadweight loss triangle, right? So the relative elasticity of the private and social costs determines whether it's optimal to have prices or quantities. And let me actually go through and do that mathematically as well. So let's say that the marginal private value is just a linear function. It's the price, or sorry, it's some reference price. That's sort of that equilibrium one that we thought it was, but wasn't necessarily exactly right, minus A times Q minus Q0. So Q0 again and P0 are those equilibrium points, assuming that we got the demand right, minus epsilon. Epsilon is our uncertainty about the actual level of the demand, right? Or of the private value. And imagine that the marginal social cost is P0 plus B times Q minus Q0 minus eta. Okay, so the socially optimal thing, if we could do it in a case-by-case thing and we didn't have to set some constant thing, would be to always take the intersection of these two. Where's the intersection? Well, it's where the p's cancel out when we set these equal to one another. And so it's where A times Q minus Q0 minus epsilon plus B times Q minus Q0 minus eta is equal to 0. And the solution to that would be Q star star is equal to Q0 plus A epsilon plus B eta over A plus B. Okay. On the other hand, imagine that we set a fixed price. And in fact, the optimal fixed price to set is P0. So imagine we set the price at P0, like we showed in that graph. Well, then the private value will determine what happens, and we get P0 is equal to this, and we get Q is equal to Q0 plus epsilon, right? So it just moves straight along with however the demand curve shifts, or the marginal private value curve shifts. On the other hand, if we set the quantity equal to 0, if we set the quantity control, then that's just at Q0. So we either have the option of getting Q0 plus epsilon, or just Q0. Now, which one of these is better? Well, the area of the dead weight loss is just this triangle, which has total slope A plus B, and has this length equal to Q minus Q0, right? So the total loss is going to be 1/2 A plus B times Q minus Q star squared. And so the dead weight loss is exactly going to be equal to the variance of the difference between the optimal quantity and the quantity that we set. So what's that going to be in each of these cases? Well, in this case, we take the difference between this and this. The Q0s cancel out, and we get epsilon minus A epsilon plus B eta over A plus B, which is the same as B epsilon minus eta over A plus B. On the other hand, if we ask what's Q0 minus this, we get negative A epsilon plus B eta over A plus B. Now, which of these is most variable? Well, they both have this negative B eta in them over A plus B, so that cancels out. We can multiply it through by the AB because that multiplies with that anyways. And what we get is that this one has variance B times the variance of epsilon. And this one has variance A times the variance of epsilon. So we're going to prefer the quantity control over the price control if A is less than B quantity, and we'll prefer the price control if B is greater than A. And that's exactly what we concluded, right? So if this was steeper, so if the marginal private value was steeper, then we prefer the price control. If the if the marginal social cost was steeper, we prefer the quantity control. Right? Yeah.
Sorry, that one might be quick. Could you just send out an email with this? Is that okay?
Why doesn't somebody scan this
Okay.
and send it to me, and I'll send it to the class, okay?
Sure. I'll do it.
We'll leave it here. Okay, so these are all public or government-led solutions, and some people have suggested that you don't really need a government-led solution to solve the externality problem. So as long as property rights are clear, people could, in principle, get together and say, okay, if you're making a lot of noise at night, right, and I don't like that, but you do, as long as either I have the right not to have noise made, or you have the right to make as much noise as you want, we can always get together and reach an efficient bargain. Either I'll pay you to let me use noise, to make noise, or you'll pay me not to make the noise, right? So you can pay him to shut it off, or if you have a right for it to be quiet, he can pay you in order to make the noise, right? Either way, you have reached basically the same outcome, that everyone gets what's most efficient, and there's an efficient bargain reached. And so a lot of people have argued that there's no need for a government solution here. As long as property rights over the thing are well defined, you can always reach an efficient bargain. And this logic is what's called Stigler's Coase theorem, also known as the Coase theorem or Coase's theorem. And it says if there are no problems with bargaining, no transaction costs of bargaining, then you always reach an efficient outcome regardless of the initial allocation of property rights. And if income effects are small, then the outcome is completely independent of property rights. So the question is, what is meant by a transaction cost of bargaining? It's basically anything that impedes efficiency, and this means that this whole logic here is basically just a tautology. It says that if there's nothing impeding efficiency, then there's nothing impeding efficiency, right? Another way to state this theorem is all is for the best in the best of all possible worlds, right? Nonetheless, it can be a useful guide in some cases. So bargaining can work well when there's a very small number of people, so it's easy for them to get together and talk. They have all the relevant information to determine what's efficient, and in particular, they know more than courts. And they know who one another are and can find one another. One example of this is that having a long-term relationship with someone can often facilitate avoiding externalities. So in your family, probably over the course of your relationship with your family, you sort of figured out how to live together without driving each other crazy. And that's because you had this long-term relationship. You could find the person who left the bathroom dirty or whatever, and you can hold them responsible. So sometimes this is an efficient way to deal with externalities. One example is a condominium association or a company town, where somebody owns the whole thing, where there's some relationship among all the people, and they internalize the externalities that way. Another example of that is cooperative firms that we talked about earlier, or the European Union. The countries try to internalize the externalities on one another, apparently not very well, but they, because of the long-term relationship between the companies. But these types of mergers don't obviously always work, because there can still, as we learned in the second lecture, be internalities within an organization.